Hello, and welcome back to AP Human Geography. Today we wanted to have that second part of our conversation about natural disasters and natural hazards, and that is our conversation about weather hazards. So when we talk about a weather hazard, we're talking about some meteorological event or the resulting conditions of that have the potential to cause damage to property and or loss of life. And the really big ones we're going to talk about, of course, are thunderstorms and tornadoes, which is our big hazard here. Hurricanes, flooding, another one of our big hazards. Drought, a big hazard for us. And wildfires are actually a big hazard for us too. So that's going to be the focus of our conversation. So when we talk about thunderstorms, we live in Tornado Alley, and so we get thunderstorms all the time. They are violent, short-lived weather disturbances that are associated with lightning, thunder, dense clouds, heavy rain, strong winds, and sometimes you can get hail and tornadoes. The geography of thunderstorms, really what you need are two or more air masses of different temperatures colliding into each other. You need a warm, moist one and a cooler one. And this happens really well in large open spaces like the Great Plains of the United States, and we get some of the most spectacular thunderstorms in the world. Actually, they're amazing. People come from all over to storm chase here. But you can also get them in mountainous regions where you have warm air masses that are rapidly forced upward by the steep sides of mountains. And that's something that happens islands, especially when you have really steep mountains on islands. You'll get some pretty violent storms that have a lot of torrential rainfall and things like that. But we're of course going to focus on our big Great Plains kind of thunderstorms. The causes, like I said, are colliding air masses. Essentially what you need is some warm moist air that gets shoved up into the colder levels of the atmosphere. And I've put a link for you to the NOAA Storm Prediction Center, so check that out. And then I've put in a nice little diagram here about how you get the conditions that lead to severe thunderstorms, since we get so many of them. So make sure you check this out, and if you have any questions, let me know in class. And then I think this is actually a really cool breakdown of what are some of the big things. You have lightning, high winds, short-term heavy precipitation, and then this is kind of a flow chart that I found about how people assess the risks and the damage from natural disasters. This one happens to be for thunderstorms, so check that out as well. And then of course, when we look at thunderstorm activity, if you were to look at the United States, and we are, you can see that this is going to be the heart, right? The heart of the nation is also the heart of thunderstorm activity. And of course, here's where we are. We are right in there. A little bit farther north of us is where you get some of the bigger storms, more tornadoes, but we are right on in that. And then you can also see over here, you've got this coastal, right? So you have land masses, and then you have air masses that are coming off the ocean here, and that can be pretty volatile and give you some pretty good instability over there too. So remember, it's not just Great Plains that have them. So there are four typical dangers of thunderstorms that I want you to be familiar with. The first one is lightning, and this is where you have all this friction going on with these cloud particles and stuff. And so you get electrical charges accumulate. Eventually they discharge to the ground or something else that has a lower potential. And the shock waves produced by this really rapidly heated air as the lightning passed through it is going to result in sound waves. And that's what the thunder is, right? But lightning can run, say, 1,000,000 volts. It's very, very dangerous, which is why we have lightning detectors at school here. All right, so high winds. When we think of thunderstorms, we think of winds, we think of tornadoes, and that's definitely one of the problems. We're going to talk about those separately. But straight line winds can be just as damaging as tornadic winds, and both of these photos in this picture are actually from straight line winds. Strong storms can generate sustained winds, right? That means like continuous, over 60 miles an hour, and they can create even stronger gusts. I mean, over 100, 150 miles an hour, depending. And that's going to include things like from your downdrafts, your microbursts, your gust fronts, when you're talking about these gusty winds. But sustained winds, I mean, those are a big deal. And you can see right here, this tree has literally been blown over and cracked at the base there. The next thing, of course, is the obvious thing, and that is heavy rain. A lot of times for us, it's going to be torrential rains. Essentially, what happens is that for whatever reason, whether the ground is impermeable like concrete or it's already saturated, the excess water really can't infiltrate into the ground, and it results in excess surface runoff, and you get flooding in the short term that often generates fast water. So here is just, this is actually a monsoon picture. A monsoon's normal, but it's still heavy rains. So it's technically not a thunderstorm picture. Just want to come clean right there. But anyway, but this is not something that is uncommon to see actually where we live. And so that would be kind of the long term. You get this standing water, and it has all the problems that standing water has: pollutants, waterborne pathogens, mosquitoes, things like that. However, for us, our really biggest problem is going to be fast water and flash floods. And this picture right here is something that we see on the news all the time. You have this family that's being rescued by a fast water rescue specialist, and they are first responders. They're specially trained because fast water is very dangerous. They have to be rescued out of their car. I would hazard a guess, given that this is a big pickup truck, and I don't know, but a lot of times people who are in higher vehicles think that they can make it across the water. It only takes a couple of inches for that water to carry your car away, and the water rises really fast in a fast water situation, a flash flood situation. And so I cannot stress to you enough, please, please, please do not take any risks when we have rains like this, especially when you're going in under overpasses here in the city. So be good drivers, and don't risk fast water, because that could be you in that picture. Okay, and then hail. Hail is exciting. Hail is where you have really big storm, right? And these little droplets get blown up into the higher levels of the atmosphere, and they freeze, and then they get heavier and they fall, and the winds blow them back up, and then another layer freezes, and then they start to fall, and then winds blow them back up. And they can range from pea size, that means that the winds were not as strong, to grapefruit-sized balls of ice that fall at really high speeds because they're falling from high up in the atmosphere, and they can cause lots of severe damage, right? And even injury. Actually, there are lots of cases where people have gotten hurt being out in hail. But you can see this hit that, right? That's a windshield. And this is this is also a car. This is the back rear window of a car, and it causes damage to houses and things like that too. So hail is a big problem. And actually, we had hail just the other day. All right, and then these are some really spectacular pictures of the bottom of some thunderstorms, and you can see this air mass is flattening out here at the bottom, and you can see the rain and all that good stuff, and it spreads out. And then this is actually the top, that anvil. The wind is blowing in this direction, so it creates this sort of little taper, and that taper is like a little arrow that will tell you the direction in which that storm is going. But this is the top of the stratosphere and the bottom of what's the stratopause? The bottom of the stratosphere. And so this storm has a lot of energy in it. All right, so which of the following may also be an indicator that a tornado is or has formed? Hail, a microburst, rapid succession lightning, lightning followed immediately by thunder or green-tinged clouds. You might be tempted at this point to say green-tinged clouds simply because that is something that we typically look for. It's like, ooh, the sky is green, that's tornadic. And oftentimes it is, but it has a lot to do with the hail, right? And so hail a lot of times will accompany a tornado. Microburst is just part of a thunderstorm. Rapid succession lightning is also part of a thunderstorm. Lightning followed immediately by thunder means that that lightning is like on top of you, because the separation of lightning and thunder is caused by distance, right? Okay, so tornadoes. Let's talk about this aspect of thunderstorms. It is a narrow, violently rotating, it doesn't have to be that narrow, by the way, violently rotating column of air that extends from the base of the thunderstorm to the ground, okay? It is caused by rotation in the storm from wind shear. The upper level winds are moving parallel. Sorry, nope, that means, I'm going to change that. Hang on one second. Yeah, okay, and now it's better. All right, moving perpendicular to the surface level winds. And I really wish that we had more time to go into, this is a crazy little mini overview of thunderstorms and tornadoes, but I really wish we had time to spend time talking about how they form, what generates them, why the hook that you see on the radar that they talk about on the weather all the time. But unfortunately we don't. So if you have some questions, ask me in class. Maybe we can do like a Y period thing. Anyway, upper level winds moving perpendicular to the surface level winds causes this rotation. And I have put a link here to the NOAA National Severe Storms Laboratory, which will tell you all about tornadoes. And then here is the formation. Essentially, the ground is providing this warm air. It blows up, and then it's meeting with this cold, dry air up top. A vortex is formed, and then that cold air actually descends, and this is where you get that updraft, downdraft situation, right? So the updraft is going to be here, the downdraft is there. And this is really much more of a spring-summer day thing, right? Because you need that warm air, right? Now, we measure the strength of tornadoes using the Fujita scale, which is now the enhanced Fujita scale, and it ranges from 0 to 5. And you can just kind of check this out. Please read this, get an idea of some of the basic things that change. You know, we see a lot of F1s and 2s here, and occasional F3, but there are F4s and F5s in Tornado Alley from time to time, and we'll talk about those later on. Okay, and then here are just some great pictures of tornadoes. And then this is actually a picture of the widest tornado, I think, on record. It was 2.6 miles. This is the El Reno storm of 2013. It was in El Reno, Oklahoma. Actually killed 8 people, but it was a very unique storm. If you have any questions about it, I'll briefly talk about it in class, but if you have any questions, make sure you ask them. But this was a very interesting storm. Very different from others. All right, so what are some of the worst tornadoes in recent U.S. history? It really started with the Waco storm in 1953. There were a lot worse storms in terms of damage and casualties. But if you have to think about it, I mean, if you think, and you do have to think about it, if you think about it, things have changed in terms of construction and warnings and just education in general. And so obviously later storms are not necessarily as damaging as earlier storms, not because they're smaller, but because we're better. So the oldest storms that I have in this list are the Waco and Wichita Falls storms, and these are the kind of the worst Texas storms. Gerald is probably our worst, one of our worst storms. It essentially decimated the town of Gerald, and one of the subdivisions there actually was just basically foundation. So it was a really, really big deal. Waco is still the deadliest storm in Texas, 114 deaths. Wichita Falls is really famous. It's actually called Terrible Tuesday, and so these are our big ones. But we get tornadoes every year, all the time, many tornadoes every year. So check those out. And then here are some more recent ones. 2011, 2013 were both real big years for tornadoes. 2013 was the Moore, Oklahoma, and the El Reno tornadoes. Alabama really got hit pretty hard in 2011. Joplin, Missouri also got hit 2011, and this was an EF5, so this is a huge, huge storm, right? So there's some of them that we've talked about. And I didn't list the Moore, Oklahoma tornado, although that was something that was in the news a lot here. All right, so when is the magic hour for tornadoes? Noon, 3 p.m., 6 p.m., 10 p.m., or 2 a.m.? Well, storms can actually happen, or tornadoes can happen anytime, but the majority of them seem to cluster around 6 p.m., mostly because weather hates us when we're coming home from work. I'm just kidding, that's not why. You have all of that daytime heating. You start hitting the hottest part of the day around 4 o'clock. So you've had all this energy that's gone in. You've got all of this heating. And so by 6 p.m. you have conditions that are perfect for the formation of storms. Having said that, though, there are storms at night, and those are probably some of the most dangerous, not because they're the worst necessarily, but because they're the ones that you can't see because it is dark. Yeah, and so we don't really know always where tornadoes are, and they have to be spotted, right? They always say, oh, a spotter says, right? And so we look at them, and so that makes them hard to see, sometimes even during the day, because they can be rain wrapped. All right, so here's just the average number of tornadoes, and boom, here we are, right in here. Okay, so we get a lot of them. All right, so let's shift to another big spiraling wind mass, which would be the hurricane. We don't actually get hurricanes, we get the remnants of hurricanes. But a hurricane is basically just a big wind mass of 74 miles an hour or higher, and then hurricanes occur in the western Atlantic. There are also cyclones and typhoons depending on what ocean you're in. But what you're talking about is a giant rotating storm that has rain, thunder, lightning, and will sometimes move into temperate latitudes, although they are forming in equatorial regions. So the geography of these guys, where they're going to be making landfall, is coastal regions in the mid-latitude and equatorial zones. The causes are you have these big, hot air masses, these pulses of air that move over open ocean. They create moisture-rich, low-pressure regions that eventually form these large spiral storms. I have put a link to the NOAA National Hurricane Center on there for you. And then here's just that transition from a tropical disturbance to a depression to a storm to an actual tropical hurricane. And you can see you have these big bands of spiraling bands of storms. And then here's just another picture of the hurricane dynamics. You've got this counterclockwise movement of winds and rain, and they'll actually spiral up and then sink down, which is how you get that eye. This is very much the same as that vortex of the tornado, just on a much, 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 much larger scale. And then when we think about hurricanes, Atlantic hurricanes form in the middle. They're caused by this pulse of Saharan air that blows off over the ocean, and then they're going to form and they are going to skate up. Usually take 3 paths on average. They'll come into the Gulf, skip outside of Florida, and then maybe make landfall on the eastern seaboard. They will come in through the Gulf, making landfall from Mexico all the way around to Mississippi or so. And then sometimes they'll form actually on the other side in the Pacific, or they'll skip over and continue on. Cyclones are going to be your Indian Ocean guys, and then typhoons are going to be your Pacific Ocean storms. They can occasionally come and zip back around this way, by the way. Okay, so how do we measure hurricanes? We measure those on the Saffir-Simpson scale. And again, guys, we're doing like an entire, year-long course in less than 30 minutes. So there's a lot of information missing in this. If you have questions, this is just an overview. So make sure that you write them down and ask them. But these are the different categories of hurricanes. You don't need to know the wind speeds necessarily, but you want to think about the differences in the damage that occurs as you get faster and faster wind speeds. Also pay attention to the storm surge, because storm surge is actually the most lethal part of a hurricane. So a hurricane is going to have the same typical dangers that you have from thunderstorms. You're going to get the high winds and tornadoes, because they do spawn tornadoes. Sometimes dozens and dozens of tornadoes. There are torrential rains and flooding, obviously, and then storm surge. And this is a mass of water that is pushed by the winds in front of the storm. Some of it has to do with the low pressure that you get on that leading edge, but most of it has to do with the winds that kind of pile the water up in front, and then they're going to push it over the land. It is different than anything like a tsunami that we've talked about before, but it is still this mass of ocean that comes over land. And here's a very characteristic picture of a hurricane. Didn't put in a lot of pictures for this because you know a lot about hurricanes. You've probably studied them in other classes. So here are just some major hurricanes that have hit. There have been lots of hurricanes that have hit the United States. Here are some big ones that you might have heard of. Galveston, 1900, the Great Storm. This, of course, hit Texas, killed 6,000 to 12,000 people. And the reason that I put this in here, first of all, it devastated Galveston. I mean, it absolutely wrecked the island, like trashed it. It's why they have a seawall there now. But this storm was key in us really mobilizing to try and figure out how to warn people about storms, how to make hurricanes safe buildings, how to protect coastlines with seawalls and stuff like that. So it was a really, really big deal in terms of our thinking and our shifting to being more proactive about hurricanes. Then there was Hurricane Camille in 1969. It is one of only 3 Category 5 hurricanes to actually hit the United States as a Category 5. There have been many Cat 5 storms. Usually they will downgrade shortly offshore and they don't actually make landfall as a 5. Andrew and Camille, okay, are 2 of those Cat 5 storms that actually hit. And I'm going to talk about Andrew in just a second. But Camille was another one that actually really changed the way that we dealt with storms and furthered that cause of really trying to get warnings, having systems, having evacuation plans. And then Texas storm, another Texas storm was Gilbert in 1988. And I bring up Gilbert not because it was a huge storm necessarily for Texas. I mean, it did. It wreaked a lot of havoc. But it actually killed over 300 people. It was supposed to make landfall in Houston, but it actually made landfall in Mexico. And I lived in Houston at the time this storm came through. And this was a big deal because if this storm had actually hit it became a Category 5. If this storm had actually hit Houston, that would have been really catastrophic to the city. And so again, there was a kind of a shift in thinking at this point. Andrew was one of those Cat 5s that hit, Category 5s that hit the United States. Andrew, for a long time, until Katrina, was the costliest, the most expensive hurricane in U.S. history, right, for a long time. It was a big deal. There was fortunately not a lot of loss of life, about 15 people, but in the grand scheme of things, while that's tragic, it's not nearly as bad as it could have been. But the actual economic impact was catastrophic. Ike is another Texas hurricane that hit us, and Ike was huge. It wasn't in the news as much as it could have been, but it was absolutely huge. So check this out. But it is actually the third costliest Atlantic hurricane in history, right? Ike, Katrina was the most expensive, and then Sandy, and then Ike was actually the third most expensive, and it just destroyed lots of places in the Caribbean. And then, of course, Sandy, which you probably remember, that was kind of unusual because it was a northeastern hurricane, but it did a ridiculous amount of damage, partly because of the geography there in terms of urban geography. There are lots and lots of people living in a very congested space, so that's a big deal too. And then, of course, Katrina, which you are all familiar with. All right, so moving on to our next hazard, and that is drought. Drought is simply a water shortage that results from a prolonged lack of precipitation, specifically a decrease in rainfall. It's going to happen anywhere that you've had a change in rainfall. And I've put a link here to the U.S. drought portal so you can kind of see drought is a problem that we have from time to time. Droughts can result in the following problem related to disease transmission is your first mini quiz question about, or your only mini quiz question about drought. So would you get a decrease in the number of cases of mosquito and waterborne illnesses, an increase in the number of cases of mosquito and waterborne illnesses, more likely epidemics of viruses like influenza, MERS, and Zika, introduction of hemorrhagic fevers like Lassa, Hunta, and Ebola? Or there is no relation. Well, interestingly enough, you can actually get an increase in the number of cases of mosquito and waterborne illnesses because droughts result in standing water. And shallow standing water can be very warm and can become stagnant easily. And so you can actually get some of the same problems with mosquito and waterborne illnesses that you actually see in flooding. So it's kind of an interesting thing there. All right, and then when we talk about drought, again, it's just about rainfall. I've just put these in there so you can see that there are areas that are just typically prone to have droughts, and then there's some areas that have droughts because they've had changes in precipitation. But one of the big deals is that when we have droughts in the Great Plains, we have problems for agriculture. And then here are just some pictures of drought because we like pictures. You can see that having a lifeguard on duty probably isn't a problem here, but you can see that this little lake area actually came far up past this sign, and then here of course are crops that just didn't make it. So what are the impacts of drought? I mean, we think about drought, well, it's not that really that big a deal, but it is actually, and the obvious thing is you have that recreation, you have lower water levels, you get crop and livestock loss, which is an economic problem caused by water shortages, poor soil quality, erosion, but you can have some things that you might not have thought of, and that would be the decrease in or more expensive hydroelectric power, right, because that lower water level is going to be a problem if you're trying to generate electricity with a dam or something like that. You have municipal municipal water shortages. It's where you get the restrictions on water use. You also can have limited inland shipping. I mean, if your drought is really bad and it lowers levels in your rivers, you can't really get boats and ships through that. And then you also have the increased risk of wildfires, right? And wildfires is our next conversation. And we're just going to talk briefly about this. I mean, it's kind of obvious. It's a fire, right? That's not controlled and can burn a large area very quickly. So the geography is going to match the drought geography, but it doesn't necessarily have to be an area that has drought. It just has to be an area that's got dry vegetation. The cause is the ignition of combustible vegetation. Can be a natural thing caused by lightning, for instance, or it can be anthropogenic. I mean, we do all sorts of things that set fires. We don't put out campfires. We throw cigarettes out the window, which is yet one more reason not to smoke. And so, you know, all kinds of things. Some people intentionally set them. Sometimes control fires get out of control, although that's not very common. And here I've put your link to the Texas A&M Forest Service, who monitors our wildfires, and the U.S. Forest Service Wildland Fire Assessment System, because a lot of times when we talk about wildfires, we think of forest fires, especially if we're thinking about California or places like that. But don't forget that we have a huge wildfire risk. Grasslands, lots and lots of wildfires, although typically property damage is going to be less because a lot of stuff is oftentimes more spread out in grasslands, or it's simply rural. And then here is a Northern California forest fire. These are all firefighters, by the way, in all these pictures, because obviously if you have a forest fire, we're going to want firefighters to put it out. But you can see the trees are burning here. This is a Texas grassland fire, and then this is another California fire, and this is a smoke jumper. These are people who actually parachute into the fire because it is hard to get to, and so they'll actually start fighting the fire once they get to the ground. And then here are some female wildland firefighters. So I thought that would be exciting for you to see in case you are interested in that career. That option is available for you. Now, the interesting thing about fires, this is a fire map around the world. You see a lot of fires that are burning all the time, and that goes back to that intentionally set fire thing. First of all, Australia is really prone to wildfires. They have lots of drought conditions, and so they have really serious wildfire problems. California has serious wildfire problems, much more serious than ours, for instance. But if you look at these equatorial regions, you see fires burning, and this is all the time. They're burning all the time. Part of this is about the slash and burn agriculture, right? So they are intentionally burning acres of forest fire to put nutrients in soil and to clear the land so that they can farm it. Those nutrients are exhausted within a couple of years because rainforests typically have very nutrient-poor soil as a rule, simply because of the way nutrients cycle through those ecosystems, and so they continue to set more and more and more on fire. So really, wildfires are much more than that's a conversation that really is much more than just about the natural disaster wildfires that we're talking about, because there are fires all over the world right now. Now, having said that, here's my statement. Wildfires should always be put out. True or false? The answer to this is actually false, right? Some natural fires actually are important, and a lot of ecosystems need fire to regenerate. Grasslands thrive with fires every couple of years. Some forests thrive with fires every couple of years. The problem is that when we don't allow fires to burn, or we don't manage areas with fire that need fire, brush builds up, and people build houses and things like that. And then those fires that do start and can't be controlled will use all of that brush that's not naturally cleared out and start to burn really hot. And the problem with this is that natural fires that eventually burn themselves out really don't damage the growing zones of plants. So the crowns of trees are really saved. Grasses, the root systems are not burned down, burned up. And so all of those plants can regenerate. But when you have these big fires that result from extra brush that built up, those can often kill forests, and so they can be really problematic. And so forest management, fire is a really big part of forest and grassland management. So just know that. So you don't want to have random fires, but by the same token, some fires should be allowed to burn and be managed. All right, so that is it for natural disasters. We'll talk more about these things in class. If you have any questions, please let me know, and I will see you next time.